Okay, so like I promised you, I told you that I'm gonna record a video for you. So I'm gonna talk about the normal distribution and the approximation. So basically, I'm going over what I went in class. Um, I'm not gonna do everything. I'm just gonna do the things that might be a little confusing, or because we have the technology issue last time, we couldn't go over that, right? So let's go over that really quick. Let's go over that really quick. Okay, so here we stay in the like that's where we left off, right? So here they talk about the normal distribution. So this is a normal distribution. They give you a definition here. They give you the PDF, right? So this is like the function, right, for or PDF for the normal distribution. Here you have to keep in mind that the expectation is the mean and the variance is sigma square. So this is the notation that they use, okay? Um, N stands for normal, and as you can see here, the expectation is the mean and the variance is sigma square. Um, and as you can see from this PDF, it's not easy to integrate like the other functions that we see before, right? Instead of doing that, we are going to standardize, like I explained to you in class before, right? So here's the empirical rule I was talking in class. One standard deviation above the mean and one standard deviation below the mean implies 68%. So this is 68% of the population. 95% of the population implies two standard deviations below the mean, two standard deviations above the mean. And this comes handy when you have some, numbers that they're nice. So you don't need the table basically, right? You can just use these numerals to compute what you need, right? But sometimes it's not easy like that, right? And three standard deviations above the mean and three standard deviations below the mean implies 99.7%, right? So this is from your slides. They go over really quick this normal distribution, so I'm gonna break it down for you in this video, so hopefully you can understand after that. So here you have the standard normal distribution. Um, Here they say a normal distribution with a random variable with mean equals to 0 and standard variance 1. It's called a standard normal distribution, and that's the notation that they use, okay? And when we're talking about normal distribution, we know it's a continuous distribution, right? So I was explaining to you in class that this notation means the same thing, right? Okay? So make sure that you know how to do that, okay? And this is normal distribution, right? Okay? Um, And here, basically they're just going straight to find the values, right? So I'm not gonna go over these slides because they're going too fast. So I want you to understand a little bit better. Like I'm gonna break it down for you. So in these slides, I already shared these slides with you. They break it down a little bit more. So if this is the first time you see this, it might be confusing, right? Um, So what is a normal distribution? So many continuous variables have distributions that are bell-shaped and are called or approximately normally distributed, right? The theoretical curve called the bell curve or the Gaussian distribution. So sometimes you might have they call this normal distribution Gaussian distribution, or sometimes they call a bell curve distribution, right? And it's also a density curve because the area is one, right? So you have to keep in mind those terms that I'm talking right now, right? And they're saying here that it can be used to study many variables that are not normally distributed, but approximately normal, right? So you can always regardless of what kind of normal distribution you have with any mean and any standard deviation, you can always standardize it, right? And use the table, the C table that I was talking about in class. So here is the PDF, the same thing, right? This is f of x, right? And that's the PDF for the normal distribution. So here they describe in more detail more things or more definitions about normal distribution. The shape and the position of the normal distribution curve depends on two parameters, the mean and the standard deviation. You know that because we talk about that this is the notation that they use, right? The mean, standard deviation. So this mean can be any number and the standard deviation can be any number, okay? Each normally distributed variable has its own normal distribution curve, which depends on the values of the variables mean, standard deviation. That's what I just talked about before. Here you can see that these two normal distributions, the one in blue and the one in brown, they have the same mean but different spread, right? Or different standard deviation. Okay. Here you have two normal distributions with different means but same standard deviation. And in the third graph, you have different means and different standard deviations. Okay. So more properties. So the normal distribution curve is bell-shaped curve. Again, normal distribution looks like this, right? Like a bell-shaped curve. The mean, the median, and the mode are equal and located at the center of the distribution. So they're here, right? Mean, median, and mode. Okay. And the normal distribution is unimodal, right? So it has only one mode. It doesn't have like two modes. Some distributions, they might have two modes, right? So it might look something like that. This might be one mode. This might be another mode, right? Actually, sometimes distributions, they have more than one. The curve is symmetrical above the mean, which is equivalent to saying that its shape is the same on both sides of the vertical line passing through the center, right? So like for example, in the case of you know that this density curve has area 1, right? And if this line is symmetrical and is right in the middle, that implies that this is just 0.5, right? That's basically it. So if I'm telling you that there's 50% here on this left side of the curve, then there's 0.5 percent on the right side of the curve, right? Sometimes we define these, we call these areas or probabilities, right? Okay. So the curve is continuous. There are no gaps or holes. So you can see from the graph that I just drew, like in the previous slide, that you can see the curve is smooth, right? The curve never touches the x-axis. Theoretical, no matter how far in either direction the curve extends, it never meets the x-axis, but it gets increasingly closer and closer, right? You don't need to worry too much about that, but it's good to know. So the normal distribution, the properties, the empirical rule, the total area under the normal distribution curve is equal to 1 or 100%. You know that already. The area under the normal curve lies one standard deviation below the mean. One standard deviation above the mean is 68%. And you know this because I just talked before about this, right? So here is, you can see how it's symmetrical, right? So this implies that this was 68%. And that means that this is 34%, about 34%, right? And then if it's 95%, you can split that value into equivalent, like the same kind of percentage. Okay. So the standard normal distribution comes handy, and this is the thing that you need to know to solve the problems, right? Since each normal distributed variable has its own mean and standard deviation, the shape and location of these curves will vary. In practical applications, one will have to have a table of areas under the curve for each variable. To simplify this, statisticians use the standard normal distribution. So very simple. You have a normal distribution with, let's say, any mean, let's say 10, standard deviation 2, right? You will have to integrate that density curve, right? I'm sorry, you will have to integrate that PDF that I showed you previously from the normal distribution. So it's not practical like to keep integrating all the time. Rather, you want to standardize these values, this mean and this standard deviation, to have something like this, right? And once you have this situation, right, the standard normal distribution, then you can find the values of the table The value, you can find the values in the table, right? So it's not a big deal, right? So this is any normal distribution. Let's say this is just an example that I made it up. This is a normal distribution, right? With any mean and any standard deviation, this is a standard normal distribution. Okay. And like I was explaining to you in class, you have to use the Z-score formula to standardize from normal to standard normal. Okay, so that's what this is what I was just saying. The C value is the number of standard deviations that a particular X value is away from the mean. You have to remember this. This is very important concept. The formula for finding the C value is the following, right? So this is the X value. This is the mean that is given in the problem, and this is the standard deviation. And make sure that you're aware that this is the population standard deviation and this is the population mean, right? Make sure that you're aware of that. Okay, so that's pretty much it. Just like I was telling you in class, the C table gives you only values to the left, like this, right? So if you see something that is to the right, you might have to use some symmetry due to the curve, right? So if you have like they're asking you for the C value to the right, you can use the same logic that this is the same as the C value to the left, right? If you have exactly the same numbers with different signs, right? Or you can say 1 minus something, right? If that's the case. So just remember again that the C value gives you the area to the left, right? Okay, the table. So here you have to the right of any C value, look up the C value and subtract 1. I mean, if that's what you need, you can do that. It's up to you. Area under the standard normal curve. So that's what I was just explaining to you before. Sometimes they're asking you things in between. I explained that in class. Remember, like if you want to find, let's say, some value between, let's say, C and negative C, let's say, well, let's put whatever number, let negative point, let's say negative 0.2, 0.5, and 2.5, right? To find this area, you have to adjust something, right? So basically, if you want to find the middle part or like the area between those two numbers, you will have to find the C value to the left once standardize it, right? And then you will have to do the same for this number. And once you subtract the orange part from the yellow part, then you will have the part in the middle, which is this part right here. Okay, so that's the logic behind it. I mean, there's more in-depth concepts, but let's keep it simple for now. Okay, so that's basically what's going on. So let's continue. So here they just telling you find the area to the left. So once they're asking you just like the area to the left, this is very simple. You just look at the table and you find your value, right? So what probability corresponds to this C value, or what area on this curve corresponds to that C value of 1.99? So let me show you how to do it. So you go to the table and you look for 1.99. 1.99. So this is 1.99. 1.99. And when you see that these two, they overlap, that's how you do it. So just remember, you take this value, that's 1.9, right? That number is 1.9. And then you take this decimal, right? Which is 0.09. And if you add it up, you get 1.99, right? That's what I'm doing. So when you see the overlap between, or the intersection between the number, the C value, right? And its decimal, that's what we want, right? 1.99. So that's 0.9767, right? So that's how you find it. So this is supposed to be 0.9767 or 97.67%, right? So that's what it's supposed to have. If they're asking you again, the area to the left, you just look at the table. You don't need to think too much, right? Remember, the table gives you the area to the left. So here, right? Here they're asking you, find the negative 1.66, right? But this area, it's not to the left, right? This area is not to the left, it's to the right. But remember, this is there's symmetry in this curve, right? So you can use 1.16 and you can find the area to the left. It will give you the same result because you know that this is symmetric, right? So if we're looking for the c-value of 1.66 is the same as the c-value of negative 1.66 in terms of area, right? So if we look for 1.66, 1.16, 1.16 should be here. 1.16. That will be right here. So that area is 0.87. If you want to round to 4 decimal places, it will be 0.8770, right? So that will be 0.8770. Okay? If that's what they're asking you. So you should get the same. So as you can see, it's the same, right? Or you can subtract 1 minus that like they did here, but you can use some logic and then after that you can, find the answer faster, right? So here they're asking you the same thing I was telling you in class, the area in between these two values, right? So again, what is the logic here? You have to find, remember the area, the table give you the area to the left, the area to the left, the area to the left. So no problem, right? In this case. So I need to find what is the area of 1.68, right? So sometimes you might see these like this, and when they're asking you questions like that. Okay, depending on what exactly they're asking, right? But let's assume that they're asking you something like this. Okay, so this will imply this is the C less than 1.68 minus the probability of C less than negative 1.37, right? So I need to find the area to the left of the C value of 1.68. So I need to look for 1.68. 1.68, so that's here. So that area corresponds to 0.9535, 0.9535 minus, now I need to look for negative 1.37. You have that here. That's right here, right? If you subtract that green that I just made from the, if you subtract that green from the pink, then you get the in between, right? So I need to find that negative 1.37. So negative 1.37 should be here. Negative 1.37, that I think that's here. That's right here. Okay. So that's right here. Negative 1.37. So that's 0.0853. 0.0853. And now it's, it's just subtracting those numbers, right? And get your answer. Not a big deal. It's really easy actually. And when you're doing that, you should get, in 1 second. You should get 0.8682. Okay, that's it. That's the area in between. Okay, as you can see, it's not difficult, right? It's very easy. Now, you see that now they're asking you in terms of probability. Find the probability between this value and this value. Okay, so you know that this will be less than 50, right? The probability should be less than 50, 0.50. How do I know that? Because you know that this area, the total, I'm so sorry. You know that the area here is 1, right? The total area. So you know that half should be 50 and this other half should be 50. So you know that this result should be less than 0.50 anyway, right? So let's try to find out what it is. Again, we use the same method, right? We can do like this to the left. And then the other one to the left. But we have that result already. We know what, so basically we just need to look for 2.32 minus C less than 0, right? Because we know that this is, sorry, we know that this is 0.50 anyway, right? Now we need to find out what's 2.32. Now that number should be about 90 something. You can estimate it a little bit, right? Or 80 or about that, right? Okay, let's find out what's 2.32. 2.32. 2.32. Let's make it simple. 2.32. That's right here. Actually, it was 90 something. I was right. 0.9898. So this is 0.9898. 0.9898. And if you subtract that, you get 4898, right? About that. Okay. So as you can see, you can just use a little logic and you can, you know, find your answer. Okay. Okay, let's continue. So here they're asking you a different question, right? They're asking you now to find the C value. So that this is a different question. Find the C value such that the area under the standard normal distribution curve between 0 and the C value is 0.21. Okay, so we know that this is what? This area is 0.21. So you don't even need to do anything here, right? You know that this area should be, well, so this is 0.2123. But you need to look for the probability of, you need to add the 50 from the half of the curve, right? Remember, this is 50, and you need to add this 0.71. So basically, you're doing this, right? And then you get, did I write it right? Yes, I did. Okay, 17. So you get 0.7123. That's the C, that probability. You need to look at the table to find out what's this C value that they're asking you, right? So if you look at the table, you find your answer. So 0.7123. Let's see what C value it corresponds to that. 0.7123. 7123. Right here, right? So I think it's this one. 0.7123. It's about that. It's 0.56. So that C value is 0.56. So the C value is 0.56. That's what they're asking, right? Or 56%. I mean, I'm sorry. Let me look again. Sorry. Yeah, the C value should be 0.56. Okay. That's what we get, right? 0.71, that was the area. Yeah, we should get the same. So the C value, as you can see, is 0.56. Okay, I hope this makes sense, right? It's just easy. You just need to use a little logic, that's all. Okay. So here they have applications of the normal distribution. The standard normal distribution curve can be used to solve a wide, variety of practical problems. The only requirement is a variable have to be normally distributed or approximately normally distributed. For all problems presented in this chapter, you can assume that the variable is normally distributed or approximately normally distributed. So when when you're doing the problems on Willy Plus, they're gonna always they're gonna tell you that it's normally distributed, because you cannot just say, oh, it's okay, I'm gonna just assume that it's normally distributed. They have to let you know that it's normally distributed. And it's good, or it's this is not a rule, but this is like, you can take it like as an advice. If the sample size is greater or equal than 30 and your population standard deviation is known, then you can use the C value, right? This is gonna change eventually when we are in the next chapters. We will have different tables, not just the C table. Okay, there will be something else, and this becomes handy later. But not for now. You don't need to worry too much about that. But it's good. Um, it's a good it's good for you to have a sample size greater than commentary. Okay. Um, so applications on the normal distribution, to solve problems by using the standard normal distribution, transform the original variable to a standard normal distribution variable by using the C value formula. This formula transforms the values of the variable into standard units or C values, right? Or the C score. Once the variable is transformed, then the procedure table and table in. Okay, so basically, if you have any normal distribution with any mean, let's say 15 and standard deviation 3, this is normal distribution. You need to convert this into standard normal, 0 with mean 0 and standard deviation 1. It doesn't matter what number you get. You can have any number that they can give you any number. As long as a variable is normally distributed, you can always standardize it. Okay? Okay, let's continue. So here they're asking you a question. They say a survey. I'm just giving you these examples because they are simpler to understand, but the application is the same for the problems from Willy Plus. They're exactly the same. I will do ones from the other slide once we kind of get a better idea how to do these problems. A survey by the National Retail Federation found that women spend on average 146.21 for the Christmas holidays. Assume that the standard deviation is 29.44. Find the percentage of women who spend less than 160. Assume that the variable is normally distributed. Do you see that they mentioned that? So that's always the case. You cannot just say, okay, whatever, the variable is normally distributed. They have to let you know. So let's do this problem. So X is normally distributed with mean 146.21 and standard deviation 29.44. And now the question is, find the percentage or the probability that of women who spend less than 160, right? Okay, so give me 1 second. I need to find something. Okay, so we just need to standardize this normal distribution into standard normal. So as you can see, this value, I already know that is this to the left, right? So it should be easy problem. So this is X minus the mean over sigma less than 160 minus the mean 146.21. Just remember, this is the mean and this is standard deviation. The standard deviation is 29.44. So now it's just computing this stuff and that's basically it, right? See, and now we need to subtract those values, 160 minus 146.29 divided by 29.44, and you get 0.468. So I'm gonna round it to 0.47. So I need to look at the table, what area corresponds to this C value. So 0.47. So 0.47 is here. So it's 0.6808. So 0.6808. And that's the answer. That's what they're asking you. So what's the question? Find the percentage of women who spend less than 160, 68% or 68.8%. Okay, that's it. So you can see here the answer, right? 68.08%. Okay. So here they give you another problem. Each month, an American household generates an average of 28 pounds of newspaper for garbage. Assume that the standard deviation is 2 pounds. If a household is selected at random, find the probability of its generating between 27 and 31 pounds per month. Assume that the variable is normally distributed. Okay, same thing. So X follows a normal distribution. What is the mean here? 28. And the standard deviation is 2 pounds. Find the probability between 27 and 31 pounds, right? Per month. So remember, they're telling you that they're normally distributed, right? They're telling you that. Okay, so same thing, right? X less than 31 minus X less than 27. Now we normalize it. X minus the mean sigma 31 minus 28 over 2 minus probability X minus the mean sigma 27 minus 28 over 2. So this is C, this is 3, right? And this is 1.5 minus C, and then this one is -1. So that's gonna be -0.5. Okay. Now we need to look for these values in the table, right? So 1.5. 1.5 is right here. 0.9332. Let me double check again. 9332. 9332 minus 0.5, -0.5, -0.5, -0.5. That's right here. That's 0.3085. Now you subtract those numbers and you get your answer, right? 0.9332 minus 0.3085, 62.47. So it's 62.47. Okay, that's it. So you can see, right? I got the same. Let me skip some problems because maybe this one might be useful for you. Here they said to qualify for a police academy, candidates must score in the top 10 on general abilities test, right? The test has a mean, so has a mean of 200 and a standard deviation of 20. Yes. Find the lowest possible score to qualify. Assume that the test scores are normally distributed. Same thing, but you have to be careful here a little bit, okay? Just one thing you have to watch out. Here, they're asking you for the top 10, right? Top 10 percentages. So, so they're asking you for basically the 90 and above percentile, right? So what you need to do here is, what is the lowest score that the person can get, right? So here you can do the following. So if you put 0.10 here, let's say if you're looking for 0.10 here, yeah, so we just need to find the lowest possible score. So we have the probability. So just remember, the formula is this. Okay, so we're looking for the minimum score. So you can just do this, right? And you can find the minimum score. So here, we need to find what area corresponds to that. You have the standard deviation, which is 20. You have the mean, which is 200. And then you will have you will find the minimum score. Or you can say this is the minimum score, right? Whatever, sorry, it should be like this. Whatever greater than that, right? Because we're asking minimum score. At least this one, actually, it should be like this. So you can do like that too, if you want, as an inequality. So we need to find that C-score that corresponds to that. If I do like this, I find the 90 score. So that will be my C value, right? Whatever to the left. So remember, when I find that, that will give me the area to the left, but I need to find the area to the right in this case, because we're looking for the higher or the top 10%, whatever. So we need to look for, if we look for 0.90, we have to subtract whatever area we get from 1 minus that area. So let's look for that. Say 0.90, right? So let's say 0.90. So 0.90 area. Okay. So the area corresponds to 0.90 will be this one. Either this one, I'm gonna use this one because it seems closer. So 1 point, this one is 1.28, right? So 1.28 is a Z-score, 1.28. So I need that 1.28 here. 1.28 times that, right? So that will be 1825.6, right? Because if you multiply, yeah, that will, and then this is 200. So the minimum score should be 225.6. Okay. That will be the minimum score that you need. Okay. So as you can see here, they have the same 225.60, right? Or 226 if they want to round to the nearest score. So yeah, 226. That's the minimum score you need. Okay. So be careful when you're solving these problems. Make sure that you understand what they're asking. So top 10% implies this one, right? So the C value corresponds to that area. In that case, will be 1.28, right? So I'm not doing this because these are the same questions, okay? You can try that on your own. You have these slides. Yeah, this is, don't worry about this. So this is why you need to worry. The central limit theorem, right? So I explained to you in class how to derive these values or how to derive these formulas. In practice, what you need to remember is that this is a good concept that you need to remember, right? A sampling distribution of the sample means is a distribution obtained by using the means computed from random samples of a specific size. Taken from the population. Sampling error is the difference between the sample measure and the corresponding population measure due to the fact that sample is not perfect, and there's always some errors when you're taking a sample, right? It's not going to be exactly the same. However, as n increases your samples, your sampling distribution, the mean of the sampling distribution will approach the population mean, and the standard deviation of the sampling distribution will approach it will be equal to the standard deviation of the population divided by the square root of n. Just remember that. So here basically they just worded what I just say, right? So you can read that. And this is basically one of the concepts that you need to understand about the central limit theorem, right? The mean of the sampling distribution will approach the population mean as n increases. Your mean of the sampling distribution will approach the population mean, and the standard deviation of the sample means is called the standard error. That's another way you can call it, right? So just make sure that you are aware of these definitions, and the formula change after that. So instead of saying x minus mu over sigma, it's going to be, because n, this is the mean, right? So this is the same as x bar now, because we're talking about means, minus the mu x, which is in this case mu, and the standard deviation should be this one, but because this is equivalent to this is the new formula that you need now.